Okay, yes. Now we are going to discuss experiment number 7, design and validation of theft alarm. So what we are going to do here, so this is our circuit diagram. Already we have discussed our design calculation. From that we have calculated R1 resistor as 10 kilo ohm and RB resistor as 1 kilo ohm. So now we are going to see how we are going to make the circuit setup and we are going to get the output. Okay, in that from the circuit diagram we need to make a small change over here. We need to connect R1 resistor here and then LDR here. Okay, this small correction you need to make it in your observation as well as the record. So R1 resistor value is 10 kilo ohm. LDR, so this is our LDR, light dependent resistor. So how it works, it's very simple. Take your multimeter, put it in the resistance mode, measure the resistance between these two terminals. So now with a high light intensity, it shows around 800 ohm, that is nothing but 0.9 kilo ohm. So if I make this LDR window to dark, its resistance becoming very high. So if it is fully dark, it give very high value. If we allow the light to fall, the resistance will get decreases. Therefore it is called as a light dependent resistor. Okay, so now what are all the other elements we are going to use? This is our LDR, this is our 10 kilo ohm resistor, then this is our base resistor 1 kilo ohm, then this is our piezoelectric buzzer. Here you have two terminals. The lengthier terminal is positive, the shorter terminal is the negative terminal. Even you can observe here, this plus mark indicates the terminal nearby to this is the positive terminal, the other one is the negative terminal. Okay, so then you have a BC547 transistor. The first terminal is the collector, the second one is the base, the third one is the emitter. By making this flat surface is the front view to you. So if you keep the flat surface is the front view to you, the first one is the collector, the second one is the base, the third one is the emitter. Now we are going to give a connections as per the circuit diagram. The very first one, we are going to connect R1 resistor in our circuit. So this is my R1 resistor. Then our LDR we are going to connect it. LDR I am going to connect it. Okay. Then base resistor 1 kilo ohm resistor we are going to connect. 1 kilo ohm resistor we have connected. Then our transistor. So actually the base resistor other end need to be connected to the base terminal of your transistor. So I am going to connect it here in the base terminal. We have connected. Then what else pending? So we have connected R1 resistor, LDR, base resistor and transistor. Now we will do one thing. We will connect the emitter terminal to the ground. That portion we will finish. So this is our collector terminal. I am going to connect it in the ground. So we are going to keep this the below line as a ground, the above line as a VCC. Okay, by making that assumption I am going to make all the connections. Then our piezoelectric buzzer, positive terminal, the positive terminal you need to connect it in the VCC, negative terminal we need to connect it in the collector terminal of the transistor. So the negative terminal I am going to connect it in the collector terminal. Then here we need to apply the positive. So positive I am taking from here and I am going to connect it here. So that's all. This set of connections were over. Now simply we need to give a DC 5 volt supply across this circuit. Okay, so how we are going to get a 5 volt supply? So here we are going to use the regulator IC. So you know we have a 3 terminals. The input terminal, this is our input terminal, this is our output terminal. The last one is this is the first one is the input terminal, the second one is the ground, the last one is the output terminal. This is the pinout diagram of your 7805 IC. So here I am going to connect it here. So the first terminal we are going to connect our 9 volt input supply from the battery. So 9 volt input supply, the positive I am going to connect it in the input. Then this ground wire I am going to connect it in the middle terminal of our regulator IC. Then the output terminal, from the output terminal we are connecting to the top bus. So this bus terminal now become positive. Now the last connection is the negative. So from the middle terminal of the regulator IC we are going to give a negative over here. That's all. Entire connection is over. Now see now the ambient light is high, therefore the buzzer not giving sound. If it is becoming dark, see if I close this window, it will give a alarm. Okay, how it is going to act as a theft alarm? So you can keep this particular setup inside any locker or somewhere. Okay, if somebody opens and if they bring their hands or some obstacle nearby to this will give an alarm. So in this way you can design the theft alarm and you can make it work it like this. That's all.